All right, in 4.1b, we're looking at how do we apply some of this exponential stuff. And a good application is compound interest. So there are some formulas that are used by financial banks or whatever to calculate compound interest. And there's two of them, okay? And there's some variables in there, you need to know what they are. So after t years, so t is always in years, the balance, which is given as A, in an account with a principal P, principal is the amount that you started with, like the initial deposit, and an annual interest rate, R. Okay, and you'd always take R and you put it in decimal form, is given by the following formulas. So for n compoundings per year, meaning it could be different compoundings, different times a year, twice a year, 4 times a year, 12 times a year, or daily, 365 days a year. So if it's n compoundings, then the formula looks like this. It's P times 1 plus R divided by n raised to the nt power. Okay? Now, if the problem says for continuous compounding, you use this formula. All right? P is still the principal. E, remember E is an irrational number. It's approximately 2.718, ... Calculator knows what E is. You don't have to remember that. But it's E raised to the R times T power. So it's exponential in that regard. Where again, N is the number of compoundings per year and T is the number of years. So let's do this. Complete the table to determine the balance A for 25,000. Balance A for 2,500 invested at a rate R for T years and compounded N times. All right. So the 2,500 is the p-value, the principal. Okay. R and T are given down here. R is 2%. T is for 10 years. Now, the table is giving us different compounding. So one compounding is an annual compounding. 2 compoundings a year is biannual. 4 compoundings a year is called quarterly. 12 compoundings, hopefully you realize, is monthly. 365 would be daily compoundings, okay? And then we have the continuously compounding. That's a different formula altogether. All right, so let's try this. Really, it's just going to be plugging in numbers in the correct formulas to get us going. All right, so we're going to let R is going to be 0.02, make it a decimal. All right, so the first one, A is equal to P, the 2,500, times 1 plus R, which is 0.02, divided by 1 compounding a year, raised to the n times t power, so to the 10th power. And I'll put that in the calculator, and when I do, I get 3,047 and 49 cents. Okay, so that's where n is equal to 1. Now, if n is equal to 2, this is going to change a little bit. It's still 2,500 principal. 1 plus 0.02 divided by 2. Now it's 2 times n compounding, or you could raise that to the power of 20. It's the same thing. When I put that in my calculator, I get $3,050.48. Okay. Now, if n is equal to 4, it's quarterly. I'm going to still start with 2,500 times 1 plus the rate, 0.02, hasn't changed, divided by 4 times n times t, so 4 times 10, or to 40th power. If I type all that business in my calculator, I get 3,051.99. Notice there's not a huge change if it compounds twice a year or 4 times a year. It's a $1 difference, basically, $1.50. But what if it compounds 12 times a year, monthly? All right, let's run that. So it's going to be 2,500 times 1 plus the rate divided by 12 raised to the 12 times 10 power. So it's the 120th power. All right, that's going to go up to, goes to 3,053, 0.00. Okay? Now let's do n is 365 at daily compounding. So 2,500 times 1 plus 0.02 divided by 365 raised to the 365 times 10 power. Okay? Put all that in your calculator, and I get 3,053.99. All right? So notice we started at 2,500. See how our investment has grown if we compound it more frequently. So then what happens if we do it continuously? We have to use a different formula for this one. Remember, it's A equals PE to the RT. All right, my principal is still 2,500. E is a constant. Okay, calculator knows what E is. My rate is 0.02 times 10, which is my time. All right, when I put that in, I get 3,053.51. All right, so that's how these investment problems work. You're just using the formulas. The formulas will be given to you. They are on the formula chart. They're the only formulas on the chart. But you just got to know which one is used for multiple compoundings a year and which one is used for continuous. It's really easy to tell. The first one has an N for number of compoundings. The second one doesn't because it's continuous. Okay, so let's try another one. It says find A for $12,000 invested at rate R for T years compounded continuously. Now, what's changing on this table is the number of years. All right, so we're focusing on this formula this time, PE to the RT. So if my rate is 3.5%, so that's 0.035. Make sure you put your decimal in the right place. So if T is equal to 1, my balance would then be initial investment of 12,000 times E to the R times T. All right, so you'll put that in your calculator, and I get 12,427.44. All right, not bad. After 1 year, you made $400. So what if T is 10 years? Okay, my balance is going to be 12,000 is still my principal. E to the same rate. This time it's times 10. When I put that in the calculator, I get 17,028.81. What if T is 20 years? You can wait and not touch it for 20 years. That's pretty good. So it's E to the 0.035 times 20. All that business in the calculator, you get 24,291.81. All right, pretty good. 20 years paid off. Okay, we more than doubled our money. It's a good deal. All right, so what if T is 30 years? You still can be patient and you can leave it another 10 years. Our principal is the same. E to the R. This time T is 30. Put that in your calculator. You get 34,291.81. What if T is 40? Principal is 12,000. E to the 0.035 times 40. That goes up to 48,662.40. Pretty good. Look, it's 4 times our initial investment. It's pretty good. What if you can wait 50 years? You've got ultimate patience, and you can hold on to that for 50 years. Do that, and you get 69,055.53. Okay, pretty good investment. Pretty good investment. So you can see with compounding continuously, you really do make more money if possible. So do that if you can. So look, at 20 years we doubled our money. At 40 years we quadrupled our money. And at 50 years, it's almost, not quite, it's almost 6 times our money that we initially invested. So it's really important to get those compounded continuously kind of investments if you can, and just to invest money and leave it alone for as long as you can, okay? So that's a great application of exponential problems.